this video, I'm going to demonstrate using the definition of the derivative using limits in Calculus 1. Now first I think I'll open a browser and take a look at an online textbook. So here's our calculus textbook. Here's our table of contents. The derivative as a function. And we find this formula. F prime of x is equal to the limit as h approaches 0 of the difference quotient, f of x plus h minus f of x all over h. So we can use that to find the derivative of a function that they give you. However, they end up using this to derive shortcut derivatives. So you won't be asked to do this on very many problems on a test. You may have a homework section where you have to do a lot of these problems, but you won't have very many of them to do on a regular test or a final exam. It can be a lot of work though, so we're going to take a look at that. First I'm going to write down that formula. We have here that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So I think I'll just choose some random function. I don't want it to be too easy, but I don't want it to be too difficult since I'm just trying to show people the main idea. So I'm going to choose f of x is equal to x squared plus x. Once you learn the shortcuts for derivatives, you will easily be able to look at this and say that the derivative of the first term is 2x and the derivative of the second term is positive 1. So off to the side here I'm going to write that we should get 2x plus 1 when all is said and done. Now to apply this formula, we would need to be able to substitute for this upper left expression, this upper right expression, and there's nothing to substitute for h. H is just h. But we can't actually simplify our answer until this h on the bottom cancels. That'll be one of the main guides for you to follow when you're working out derivatives on your own. So for the upper right, we know what that is. That is x squared plus x. We can use this formula to find a corresponding formula for f of x plus h. What this meant was whatever you plug in for x, you have to square what you plug in and add what you plugged in again. So over here, whatever I plugged in gets squared and then I add it again. Except I did not plug in x, I plugged in x plus h. Now, to make the rest of the problem easier to work out, I'm going to simplify this by working out the square and lowering the parentheses and combining like terms. If you FOIL this out, you will get the same thing as following the pattern taught in algebra class for perfect square binomials, where you do the first thing squared, leave some room, and then do the last thing squared. In the middle, you're supposed to get the first thing times the last thing times an extra 2. So we get plus 2hx. Oh, that's terrible handwriting. I'll try to clean this up as we go on. There is no 1 or no negative on this group, so it is possible here to just drop those parentheses. And we get x squared plus 2hx plus h squared plus x plus h. And there's no like terms there at all. So this formula would plug into the upper left of the difference quotient, and this original problem would plug into the upper right, and then h is just h. So we have everything we need to be able to start working the algebra for this. We would say that f prime of x is equal to the limit as h approaches 0 of f of x plus h, which would be these terms, x squared plus 2hx plus h squared plus x plus h minus f of x, which is these two terms, x squared plus x all over h. Now, as I mentioned a moment ago, we won't be able to finish this until the h on the bottom cancels. At this point, we have a lot of work to do on top, but if you'll notice, this group has x squared, this group has x squared, and when you do x squared minus x squared, they will cancel. In a similar way, this group has plus x, and this group has plus x. And when you do positive x minus positive x, they cancel. So our next step will be to have the limit as h approaches 0 of 2hx plus h squared plus h all over h. Some people will start canceling h. If you don't make a mistake, that's all right. The proper way to show that work is to factor out h from the top. We would have h times the leftover group, 2x plus h plus 1. And then the h on the bottom is still there, except that these h's cancel. And now we have the limit as h approaches 0 of 2x plus h plus 1. Now, if the value of h changes, there will be no effect on 2x, and there will be no effect on positive 1. But as h goes to 0, the second term goes to 0, and our result becomes 2x plus 0 plus 1. And of course, 0 plus 1 is 1, and we get 2x plus 1. And that confirms my suspicion that we should get 2x plus 1 for the result. Now, after they teach this long definition of the derivatives, they teach a series of rules that allows you to do it much more easily. So that's what everybody has to look forward to in calculus class. I hope you found that helpful. If you'd like to thank me by making a donation to my PayPal account, I've provided a link below the video in the description. If you're interested in hiring me for an appointment, or visiting my live stream where you can get help with a single problem at a time, instead of hiring me for an entire hour at a time. My Twitch page is located at the link provided in the description below the video, as well as my Facebook page. Information about prices, including the amount that I charge per hour and group rates, and also the amount that I charge per problem and the live streams, is provided at those locations. To actually schedule an appointment, you can contact me directly by email. And I thank you for watching the video.